Okay, solving inequalities. We want to look at how we can solve inequalities. Now, if you are dealing with inequalities, you simply use the same approach you would use for equations. So in our example here, we have 2x minus 1 is greater than 3. So if we're going to solve this, what do? We take the minus 1 to the other side. We get 2x is greater than 3. Now it becomes a plus 1. 2x will become greater than 3 plus 1, that's 4. To get your x, divide both sides by 2, right? That cancels off. You get x is equal to 4 divided by 2, 2. Sorry, that is not an equal sign. That is not an equal sign. X is greater than 2. So when it's like this, I've solved my inequality. Okay? Now, I can have a situation like this here. It's still an inequality that we use the same approach as equations, but there's one little difference between inequalities and equation, and I want to use this example to show you that. So if I have x and I take 4, this side becomes minus 4x, less than 8, take 2, that side minus 2. So this becomes minus 3, x is less than 6. So in this case, I have to divide both sides by a negative 3, a minus 3. Now in inequalities, always make sure that if you divide both sides by a negative, right? If there's a negative, you change the direction the sign is facing. So the sign is facing that direction, you have to change it to face the other direction. So x becomes greater now than minus 2. So that's our result. So this is what you need to be careful and take note of, right? Whenever you divide by a negative, you need to change the sign so that it faces the opposite direction. Okay, so now we've got another inequality here. 2 is less than x plus 2, which is less than 8. Now, what do you do with something like this? Whenever you have something like this, you need to split it into two inequalities, right? So you take the first part here, right? 2 is less than x plus 2. Make sure you include everything in the middle there. So 2 is less than x plus 2. That's one part of it, right? And then you take the other side now. Make sure you include everything in the middle, right? X plus 2 is less than 8. So x plus 2 is less than 8. So as you can see, x plus 2 appears in both inequalities, right? Whatever was at the center appears in both inequalities. So you solve these inequalities separately, right? So this one, I take 2 that side, I get 2 minus 2 is less than x. So 0 is less than x. I've solved that one. I move to this side, I take 2 the other side, x is less than 8 minus 2, x is less than 6. I've solved that inequality there. So what do I know? X has two qualities, right? X is bigger than 0 but less than 6. So I combine this into one statement, right? X is bigger than 0 but less than 6. So x is a number whose value lies between 0 and 6. I've solved that inequality. Okay, so now you can have a situation where you are asked to list integers satisfied by a particular inequality. So let's say you've got your inequality 2 is less than x, which is less than 5. This means that x is a number between 2 and 5, right? Remember, if we're going to draw a number line, you would have 2, 3, 4, 5, right? So x is greater than 2 and less than 5. So when they say list integers, right? Integers are whole numbers, no fractions involved, right? So integers which fit into this region here. The integers are 3 and 4. 3 and 4 are the numbers that are bigger than 2 but less than 5. So 3 and 4 are your answers for that there. List the square numbers that satisfy the inequality there, right? So our inequality now is numbers bigger than 0 but less than 10, right? So between 0 and 10. So what are the square numbers? that are between 0 and 10. We have 1, 4, and 9. So 1, 4, and 9 are the square numbers that are found between 0 and 10, right? Bigger than 0, but smaller than 10. So that's that for the first part of inequalities, solving them.